Hi, I'm Navy Dowdy. Last winter, local science and engineering advisors teamed up with students at D.C. Everest High School to build a robot. The object of the project was to create a large, high-energy, visible contest so that the 30 million kids that see it on national television can see that science and engineering can be fun and exciting. The sad fact is that our students in America are testing last in the world against other industrialized countries in math and science. Council on Competitiveness just did a study that shows that our students vote to become lawyers, psychologists, photographers, musicians, and pet care specialists. In fact, more kids want to be pet care specialists than all the science and engineering professions combined. The U.S. FIRST project is an attempt to reverse that trend. Students and their advisors from all over the country had just 7 weeks to invent and develop a robot to shoot soccer balls into a goal. We got 3 points, and we got the balls in the upper goal, and 1 point for balls in the lower goal. We competed in 2-minute time intervals against 2 other robots at a time. We competed against 45 of the largest companies in the country and won the Motorola Quality Award, came in 10th in the contest, and were just edged out by Xerox for the Chairman's Award. If you would like to make a contribution to help with next year's project, call me at 845-4367. And now here's how we developed IOmega, the robot.
and celebrities? Take a look at Tower Power.
It's an unusual game that shows kids that science really can be fun. High school students team up with real engineers from big companies and universities across the United States. All the teams are given boxes with a bunch of parts in them, and their job is to build a robot. Not just any robot, a robot gladiator. These guys really move.
Okay, ready, get set, go.
Teams and their robots have 2 minutes to pick up the balls and put them through the goals on the tower. And there's a lot of different ways to get the balls up there.
You get a point for each ball in the lower goal, and then there's an upper ball. You get 3 points for each ball.
Sounds easy, right? Not. Kids driving these radio-controlled robots will tell you they can be tough to handle, and you have to watch out for the other guys. Dean Kamen is the guy who came up with this idea. He wants to make math and science more interesting to kids.
If you're going to do any exercise, you ought to do it to the muscle between your ears. And if we can put this kind of activity in the same format as football or basketball, an event, winners, losers, competition, all the stuff that makes physical events exciting also makes intellectual events exciting.
When Kamen was younger, Kamen was so bored he flunked out of college. But he was smart enough to go on and invent a medical device that helps people. And that made him a lot of money. He's a millionaire who owns his own island, all because of science. He wants kids to know there's money and fame in science, and it's not just for geeks.
The role models that they're seeing out there, the scientists and engineers from these giant companies, are not the stereotypical old, deranged, antisocial people. They're young, they're women, they're minorities.
Everybody who has competed in Tower Power really seems to love it.
I'm planning on going into engineering, and I'm planning on attending a college that provides engineering background and stuff. I'm really interested in it. And this just gave me a hands-on opportunity to work with machinery and stuff to get a feel of what it is, what it's like in the real world. I've had a lot of sciences in school and stuff. I haven't always been a good student in school, though. But when this came around, I liked using my hands and stuff.
Before I was like, well, what am I going to do after high school? But now I'm thinking of maybe going into the field of engineering.
We're going to Disney World!
Tower Power's top winners get to take home trophies and a chance to meet President Clinton. I wonder what these robots will do in the White House. Maybe take over cleaning? I'm Kat Riddle in New Hampshire with Real News for Kids.
So this is mainly a defense. And then have 2 or 3 rollers depending on how you have into the goal. Okay. And then there's a cage on it, which is so basically when you start off, there's 2 cages on the bottom, and you lift it up. So the top cage comes out, the bottom cage is still here for future use for bring more balls. You lift it up, and you tilt it, and then either have a coupler, like some type of this. out in 15 seconds. Just snap the wheels. Well, unless we had the second, had like a second cube to bring them in.
When you record it, when you hit the button, you have to point it.
There.
So you know your grandpa screwed up.
I think what we'll do here is
All his fault. What a kid.
ready? Right? Throw the ball in there and see what happens. It's a historic moment. Need more pressure, don't we?
Come on, Benny. They're competing against you now, Benny. Guess what? You need to get closer. You gotta keep it close. How you can fix this belt is off center. That's what's wrong with it. Off center? Yeah. This belt, that belt right there. We're gonna have to get someone that's good enough so we don't have to. But I think that's a good idea. I don't think it would only 5 minutes. I think we ought to just do it.
These are the award-winning driver and pickup driver of the IOmega RoboJack competition from this afternoon at NTC.
Right, they'll be competing against two other teams on the same field. This is 1/4 of the field. The whole field is 34 feet across. So while they're trying to shoot their balls into the goal, there'll be other teams blocking them and running into them and actually trying to lift it up and throw it outside the playing field. So defensive strategies are okay. In fact,
And the next one is 283. Looks like it's perfect, doesn't it?
No, we don't have much left. Maybe.
Not much room left?
What do we make it?
Get the balls quick.
Ball.
We're going to push it way down there, way up.
There it goes. Photography by Linda Lawrence.
Done at last.
Done at last.
Who is?
Mr. Guy.
Mr. Crumpy driving.
Here we are at the airport. Canceled flight. Start of our trip. There it is. Hard at work. 10 o'clock at
Notice the
night.
heavy eyelids in that picture.
Still working.
Still working.
What is that?
This is professional journal.
Professional journal. These guys are studying.
You guys, that's great. You can read a test when I can read.
Probably checking on some homework problems here.
Yeah, sounds good.
Yeah.
And passing their size check. 9X Somerville High School team passes their size check.
Power South, MIT, Honeywell North, High School. We have an opening.
They put too much spin on it.
Yeah, I know. Well, what happens is they aren't controlling well enough the speed of each one.
Yeah.
So that's the thing. So going at different speeds. Could have direct drove them.
But all that spin just gives energy to the ball.
Right.
That the only thing it can do is make it more random.
Right. So that's why if the two wheels are going at the same rate, though, you'll have no spin.
Oh, you're right.
See, so what they have is they get a lopsided. They should have driven them individually.
You should have put a belt.
Gun belt with two drives. That's right. Oh, they got him lit.
That's great.
Yeah. As long as you don't break it, they should have hit him with the back of their machine.
10 seconds. 5, 4, 3, 2, 1.
A winner! Tell them why they should participate in this.
Engineering is becoming a lot more open to females and ladies. Girls, there's a lot you can do. I got to drive the machine last year and we won. I got to go to the White House. I got to meet the president. I'm going to be flying to Chicago next month to see Dean Payne and get his big award. All of this is paid for. It doesn't matter whether you're a girl or a boy. It's your mind that counts. And girls can get in there
Okay, guys. Remember, don't touch it until you see the handball. Ready? Seconds.
Machines are coming.
Hi, Mom. WPI, SNC, and E-Systems, please go to the on-deck area now.
Miami, are you with me?
I'm with you.
Ready, let's snap.
School team. Official results match 36.
This thing up and bring it to its riser on stage.
No, what the plans can be exciting, and the Chairman's Award is really about what U.S. First is. What U.S. First is about spreading that message, the message of science, of its importance, of its excitement, its accessibility, and what it can mean and must mean to kids all over America for America's sake in the 21st century. The next, Navy Downey at D.C. Everest High School, Schofield, Wisconsin. This is another first-time team. And again, it was somebody who saw the 2020 video, a local entrepreneur. And he said, hey, this is something we got to be part of. I said, let's do it. So he in Dean Kamen style, set out to do it. He recruited a collection of scientists from the area, put them together into a team, and engineers, and they made calls. They signed on the local high school, and they got together. They were put together, broke into teams. Everybody worked at it. Tech ed kids, art department, music department. They really tried to include all the disciplines and all the departments of the school. They did. They really reached out, and they built an absolutely first-class machine, which, as a matter of fact, as you noticed, won the Quality Award. They were the little town that could. They were the little engine that could. They did, and we're glad to have them. They did a first-class job. We're all really proud of them.
But could they put out the flames? Where there's flame, there's fuel, ignited in the presence of oxygen. Moisture and pressure can exclude oxygen to squelch a flame. Scale this up 10 million-fold. Now you're facing a problem so vast that anyone tackling it stands to get more than their fingers burned. Brian Smith has this report.
Kuwait, and the now familiar scenes of the horrific bonfires of the insanity. Almost 700 wells sabotaged. Intense environmental concerns mixed with fraught, but too pessimistic predictions that it could take 5 years to extinguish.
Out of the ashes of that conflagration have arisen a number of alternative technologies, like SAFER here. SAFER is Subsea's automated fire extinguishing robot. It's a sophisticated machine that can work under the most inhospitable of environments.
All the systems are protected and all the electronics are protected and shielded. So you can go into extremely dangerous environments, particularly explosive environments, without the risk of creating an explosion or creating any further risk.
What sort of temperatures can it operate at?
We've had the vehicle working at a burning wellhead with temperatures of 2,500 degrees and working in that environment quite comfortably.
Heat protection comes from a stainless steel reflective shield. Temperature sensors, as well as 3 pan and tilt video cameras, keep track of the operating conditions. And, if needs be, a sprinkling system will enable the 30-ton robot to keep its cool.
It's hardwired. This umbilical cord contains a power supply, and within this yellow sheath is the communication system. Data lines feeding back the information from the temperature sensors, but coming in the opposite direction are the computer signals to control the tracks, the tool, every function that is normally controlled by a human driver. And as well within here are the coaxial cables leading to the video cameras. So like a giant optic nerve, this leads from the robot's eye back to mission control.
While it may look ordinary, Mission Control is an explosive-proofed container that can also withstand temperatures of 1,500 degrees for over an hour. It's from here that we'll attempt to fight our simulated oil well inferno. And allowing a little for the inexperienced, SAFER, the fire-snuffing robot, is soon in place. The portable chimney directs the flames upwards, where a torrent of water from SAFER snuffs out the flame. Even in the presence of volatile gases, there's no chance of SAFER itself sparking a further explosion. The 75 horsepower motor driving the robot's main hydraulic pump is electric and totally sealed within a tank of water. Likewise, the control system motor. The unusualness of the system makes more sense when it's understood that Subsea, as a company, makes remote-operated vehicles for work on the sea floor, servicing the rigs and welding pipelines. The technology of powering robots under the sea was easily adapted to create this land model, a sort of customised trench digger with a versatile front end. Instead of the chimney, these jaws can grab onto the most difficult of problems. In times of war, burning barricades can be lifted aside with safety for firefighters to gain easy access. What's more, it could also be rigged with the necessary equipment to search out, identify, and destroy landmines and other devices with a tendency to go bang when least expected.
If this fire were in a toxic waste dump, human firefighters would not have to put their lives at risk. You could just send SAFER in. What about a nuclear reactor, Chernobyl? Well, radio-controlled robots are at risk under such circumstances because radiation can destroy their integrated circuits. But with the hard wiring, the control coming through the cabling, SAFER can go where no man and most robots fear to tread.
While this technology was developed in response to the Kuwait crisis, it never had a chance to fight those fires. It now sits ready, though, looking for a future role should tomorrow bring disaster.
For 12 hours at a stretch, and it has an impressive combination of sensors to detect anything out of the ordinary. The US Army alone has 112 centers across the country, and it's estimated each one loses $2.5 million of equipment each year. Humans are no longer capable of keeping an accurate track of it all, so they're training a machine to do it for them. Around the midriff, 24 ultrasound sensors to measure the distance out to 10 metres. Any sound wave changes in that range indicate movement. Above them, 48 passive infrared sensors, half looking down, half looking up, to cover a 360-degree field to detect more rapid and slight variations, such as a leg or arm movement. At the same time, they help track the eyes of MDARS, the cameras on top and bottom. The camera will automatically point in the direction indicated to give an overall picture. Microwave motion detectors have the added advantage of allowing MDARS to see through walls. At the top is an acoustic array, 3 microphones to pick up any sharp sounds and to localise the direction they come from. The robot can be manually operated from a central control room, or its patrol pre-planned through a computer-aided design program which provides the layout of the facility and a series of reference stations which it uses to find its way about. Precise dead reckoning keeps it a constant metre from the walls. As a stockkeeper, MDARS has no peer, using a radio frequency antenna to read product tags so that any mishandling or removal can be immediately assessed. And unlike a human guard on patrol, the robot knows if a door has been opened and closed again by scanning a balanced magnetic switch disrupted by a possible intruder. Trying to elude or stop MDARS is made a little more difficult by a second array of ultrasonic beams. Now, it's part of the collision avoidance system. What it is ultrasonic beams being transmitted in sequence every second to give the shape and location of this object. It then is given a map to get its way around this object as quickly as possible. With a top speed of just 2.5 kilometres per hour, the robot is not designed to chase and catch intruders. It doesn't have to, because by this stage, it would have triggered all the necessary alarms to bring security guards and police to the location. And when it's done a full shift, MDARS will put itself to bed to recharge the batteries so that it will be fully alert for tomorrow night's patrol.
How to sleep in the snow and